In the last video, we discussed about how do we construct a frequency distribution table for a numerical data set, okay, or we also call grouped frequency distribution table. So here I'm going to do a complete example, okay. So here the number of stories in each of the world's 28 tallest building is listed above, okay. So these are the number of stories of the top 28 tallest building. So one building has 54 stories, another has 79 stories, 100 stories, and so on. So let us answer the question. What is the width of the frequency distribution with 5 classes? So number of classes is 5, right? So how do I find out the width? To find out the class width, we can denote by class CW. It is highest minus the lowest. That is 102 is the highest, the lowest is 54. That is the lowest data, right? Divide by 5 is the number of classes because it says 5 classes. So if you do that 102 minus 54 divided by 5, you'll get 9.6. And whatever decimal number you get, you always round up. That will be 10. So the class width will be the 10. Okay, always round up to the nearest integer. Next, find the class limits. So to find out the class limit, what we do is we first pick the first class, right? So class limit. Okay, so for the first class, the first number of the first class, or the lower limit of the first class, is the smallest value, that is 54. And then through, and all the data are integer or whole numbers, they do not have decimals, right? So the upper limit of the first class will be 54 plus the class width is 10 is 64 minus 1 will be 63, that way. Okay, now to find out all other limits, you add that class width 10. So it will be 64, 74, and so on. This will be 73, 83, and so on. Okay, so that's what you do. So basically, you need to find out the first class first. The lower limit of the first class is the smallest data. Upper limit of the first class is the lower limit plus class width minus 1 if there is no decimal, minus 0.1 if there is 1 decimal, minus 0.01 if there is 2 decimal, and so on. Okay, all right. So to find out the class, since the lowest data is 54, the class width is 10, the lower limit of the classes are obtained by adding the class width to the lower limit of the previous class. So 54, 64, 74, and so on. Okay, the upper limit of the first class is 54 plus class width is 10 minus 1 because there is no decimal is 63, and all other will be obtained by adding the 10 to these previous class upper bound or upper limit or lower limit. Now to find out the class boundary, there is no decimal in the class limit. So what we do, you add 0.5 to the second number and subtract 0.5 from the first number. So it will be 54 minus 0.5, 53.5 through 63.5. Add on the upper limit and subtract from the lower limit. Okay, and you do 64 minus 0.5 is 63.5, 73.5, and so on. Okay, you see that there is a gap. This is the class limit. That's why there is a gap between this number and that number, right? But there is no gap here. So you see that they are the same. All right, we found the class boundary. Now what we do next is we count how many data are between 53.5 and 63.5, or 54 and 63, including 54 and 63. Okay, so let's do that. How many data are between 53.5 and 63.5? Let's go to the data between 53.5 and 63.5. This is 1. Okay, this is 2, this is 3, this is 4, this is 5, 6, and then 7, right? These are the values, these are the data points that are between 53.5 and 63.5. All other are bigger than these. So how many? 1, 2, 3, 4, 5, 6, 7. So here I am not making the tally marks because tally is too simple, so you don't have to do that usually. You just write the frequency. There are 7 data points between these two numbers. Similarly, count how many data points are between 63.5 and 73.5. Similarly, 73.5 and 83.5. These are the data points I got after I counted those. So the total number of the data is 28. That's what you get. So the sum of the frequency is 7 plus 7 plus 7 plus 5 plus 2 is 28. Meaning sum of the frequency is 28. Meaning the total number of data points is the total sum of frequency there. Okay, guys? All right. Now, the next thing we do is we need to find out the cumulative frequency. To find out the cumulative frequency, what we do is we write less than and all the lower limits, and then also the upper limit of that. So how do I do that? Are there any data less than 53.5? No. Okay. So the less than 53.5 is 0. There are 0 data because the smallest data was 54 in the data points in the given data set. Okay. So the less than 53.5 is 0. Now less than 63.5 is that number, that many, 7. Less than 73.5 will be 7 plus 7, that is 14. Less than 83.5 is 14 plus 7 is 20. 7 plus 7 is 14 plus 7 is 21. There is 21. 21 plus 5 is 26 plus 1 is 2 is 28. That's what you get. Okay. So the last value and the sum will be the same. That is the cumulative frequency. This is how you find out the cumulative frequency. Let us look at one more example with the decimal values in the data set. Okay. You see that there is 0.5, meaning all the data, most of the data have 1 decimal after the data set. So we need to answer the question, similar question. All right. What is the width of a frequency distribution with 5 classes? What is the highest data point? Highest data point is this. What is the lowest data point? Lowest data point is this. So to find out the class width, the formula is highest minus lowest over number of classes is 5. So if you do that, you will get 10.72, which is 11. Always round up. 11. Okay. So how do I find out the class limit? Class limit will be, the smallest is 0.5. Okay. And then through add 11, you will get 11.5. Okay. Because the upper limit will be the lower limit plus class width is 11.5 minus 0.1. If there was no decimal, you will do minus 1. Since there is 1 decimal places, you will do minus 0.5. So that will be 11.4. So 11.5 minus 0.1 will be 11.4. That's what you get. Okay. Now to find out all other class limit, you add the class width. So you do 11 here. You add 11 here. That will be 11.5 and add 11 here. 22.4. You see that? Similarly, add 11 here. You will get 22.5. Through you add 11 here. 33.4 and 33.5. Because to find out the lower limit of the second, third classes, you add the class width to the previous lower limit. And for the upper limit, add the class width to the previous class and continue that way. Okay. So one more there. All right. That's what you do. You see that? 0.5 through 11.4, 11.5 through 22.4 and so on. And how do I find out the class boundary? Okay. So the class boundary is, if the class limit do not have decimal, you add 0.5 on the bigger number and then subtract 0.5 from the lower limit. Now to find out the class boundaries, since there are 1 decimal values, what we do is you subtract 0.05 from the lower limit and add 0.05 to the upper limit. So it will be 0.45. If you add 0.05, if you subtract 0.05 to 0.5, you will get 0.45. This will be 11.45. That's what you get. You add to the upper limit. Similarly, subtract from lower, add to the upper. That will be 11.45 through 22.45 and continue that way. Okay, that's what you do. So this is what you get for the class boundary. Now to find out the frequencies, you count how many data are there. Okay, for example, how many are between 0.45 and 11.45? Let's count. 1, 2, 3, 4, 5, 6, 7, 8. And I think that's all, right? So there are 8 data points between 0.45 and 11.45, or you can say 0.5 and 11.4 including those 2 values. So these are the values. And then so what you do is in the frequency column you write 8 for that. Okay, let me show you how I did that. There are 8 values. Similarly, between 11.45 and 22.45, there are 5 data points, and continue that way. That's what you get the frequencies. Now, to find out the cumulative frequency, what do you do that? So let me do that, cumulative frequency, okay? So to find out the cumulative frequencies, so what you do is you write down cumulative, CF is the cumulative frequency. You write down less than, and then write the smallest class boundary, 0.45. Okay, since the smallest data is 0.5, so there is no data less than 0.45, so you write down 0. So you write down less than, you copy the less than, same less than 11.45, 11.45. Write down the first one. This is 0, this is 8. Okay, now for the next one, so what is the next one is 22.45. So less than 22.45. You copy the same thing here. Okay, same thing. Is 8 plus 5 is 13. Another one will be 13 plus 3 will be 16. Another will be 16 plus 1 will be 17, and then 18. That's what you get. So what is the next one is 33.45. 33.45. Copy the less than here. Copy less than 44.45, and then the same thing 55. The last one will be the upper bound. Okay, 55.45 is 18, which is the total number of data points there. Okay, guys, this is what you do. Okay, so this example is very much similar to the example 3. So you do that by yourself. Actually, I have done it here. Okay, I have done how to do all all this frequency, but you can do the cumulative frequency as well on the side there. So how that look like? Less than 15.5 will be 0, less than 22.5 will be 10, and next one will be 10 plus 11, next one will be that plus 6, and so on. All right. So example number 7 is, which of the following table is incorrectly constructed? So what is the correctly constructed and what is the incorrectly constructed is, so we are assuming that the class limit is given here. Okay, so these are the class limit. Let's say class limit, and class limit, because there are gaps, right? So we assume that they are class limit. Class boundaries do not have gaps. Okay, so what types of table are incorrectly constructed? That we need to know that first. So the table is not correctly constructed if the class width in the different class are different, not same. Okay, that is one situation that the class are not correctly constructed. If some classes have width 5, another class have width 7, like that, so it is not correctly constructed. Sometimes the gaps between the class are different. For example, the gap between 22 and 23 is 1, and then another class may have bigger gap. Okay, that is not the right way to write. Okay, all the gaps between the class must be the same if they are correctly constructed. Okay, and sometimes there is no gaps, there is 0 gaps, and there is 1 gap, 2 gap, like that. So the gaps between the classes must be same, the class width must be the same. Okay, and then class should not be missing, meaning the gaps should not be bigger than the gaps between the other classes. Okay, let us look at that. On number A, the class 45 through 49 has how many data, or what is the width of this class? So 45, 46, 47, 48, 49, 5 is the width there, right? Because 1, 2, 3, 4, 5. So 5 of the data, I mean the data that lies between 45 and 49, including 45 and 49. That means these data, these many data. If there are data with these numbers, then they are included there. So the class width. So the class width of this class is 5. Okay, but all other class have class width 6. What is the class width of 27 through 31? 27, 28, 29, 30, 31, 32. So 6. So this has class width 6. This has class width 5. They are different class width. So this is not right table. Number B is class 17 to 20 have class width 4, and our other classes has class width 3. See, what is the class width of 5 through 9? 5, 6, 7, 8, 9. Oh, they're a class with 5. 9 through 13. 9, 10, 11, 12, 13. 5. Oh, the other have class with 5, not 3. Okay, other have class with 5. So this one has 13, 14, 15, 16, 17. This one has 17, 18, 19, 20, 4. And another way is, so these are the class boundaries there, right? Because these are the class boundaries. Oh, by the way, even if it is a class boundary, it is not correctly constructed because of the class width. Okay, although I wrote limit, but if it was a class boundary, if the limit was not given, okay, if the limit was not given, then you can say that this is the class boundary. Why? Because there is no gap. No gap means it is a class boundary, but the class width are not same. That's why it is not correctly constructed. Number C, a class is missing between 128 and 132 and 138 to 142. See, there is gap 1, but there is gap, how much? Is that 6 or 7? So the gap between this class and that class is 1. The gap between this class and that class is 7. This class and that class is 1. So the gap is not right. So this is not correctly constructed. The last one is, it says the last 2 classes have different width than the first 3 classes. So what is the class width here? 9, 10, 10, 11, 12, 13, 5, right? What is the class width here? 29, 30, 31, 32, 4. So the class width are not same. So none of these are correctly constructed. That is the answer. Okay, guys? So this is how we make a frequency distribution table for the numerical data, or if the data have numbers. Thank you.